All right, we're going to continue on. We're going to skip 9.6, and this is actually 9.7. To recap, if you have the square root of 36, that could equal positive 6 or negative 6, and we can write that as plus or minus 6. 625, the square root of that is 25, and then that negative out front, it would still be a plus or a minus. So this would be the square root of 4 over the square root of 25, which is 2/5. And this would be plus or minus 10. So when we're solving this, you would take the square root of each side. So x would equal positive or negative 2. This would be impossible. There's no number times itself that equals negative 9. We could divide this by negative 1, solve for x squared before, and then when you square root each side, you would get x equals plus or minus 7. So just to remember, the square root of x squared is x, because x squared is x times x. We're going to subtract 5 from each side. We have x squared equals 0. Therefore, x would equal positive or negative 0. Positive or negative 0 is just 0. So that would be our answer. Here we would add 49 to both sides. So 16x squared equals 49. Next step would be to divide by 16. So x squared equals 49 over 16. And then we're going to square root. Pretty much you're square rooting the whole thing. So that means that x equals square root of 49 over square root of 16, which is positive or negative 7 over 4. If you want to write that as 1 3/4, that's totally acceptable. Either one is fabulous. Whoops. All right, so now we have 100x squared equals negative 49. You can stop right now. If you don't know you can stop right now, you would divide by 100. But this negative right here makes it impossible for now. We're going to get into imaginary numbers by the end of the year, but for now, x has no solution. All right, since these aren't going to be perfect square roots, we'll estimate them with a calculator. If you can take the square root, though, you should do that. So we will subtract 90 from both sides. You might be thinking this is no solution, but what you need to realize when you divide by negative 3, you get a positive. So, whoa, I have an x cubed. Okay. So when you take the square root of both sides, before you just type that in your calculator, let's kind of think. The square root of 25 is 5. The square root of 36 is 6. So the square root of 30 is most likely going to be somewhere in between 5 and 6, probably like 5.45, I'm guessing. So as I'm typing in my calculator, 5.477. So x would equal plus or minus 5.477. 3 decimals is a good amount to go out to. All right, this this rectangle is twice as long as it is wide. So let's go ahead and write the length and the width. If it is twice as long as it is wide, that means that instead of L, we can write this as 2W. Twice as long. The length is now twice the width. Area is found by doing length times width. We no longer have an L, so we're going to write this as 2W times W, equaling 578. So we have 2W squared equaling 578. In order to solve that, we will divide both sides by 2. Hold on here, I need that to be an 8. So W squared equals 289, and then taking the square root of that, it is exactly 17. In this instance of the story problem, the negative 17 doesn't make sense to have dimensions of a rectangle of negative 17, so we're just going to work with the 17 here. Therefore, the width is 17, and since the length is twice the width, the length is going to be 34. So the dimensions are a 17 by 34 rectangle. And I just want to add in maybe 3 small problems from 9-6. And I just want you to write these on your sheet. If you had something like 0 equals x squared plus 7x plus 10, this is factorable. So you could factor that as x plus 5, x plus 2. So the two zeros are at negative 5 and negative 2. Okay. If you have something that's not factorable, something like this, the easiest way to figure out the zeros right now is to find the line of symmetry to figure out what's going on. So A is 1 and B is 6. So we're going to have negative 6 over 2 times 1, which is negative 3. That's our x value. We're now going to plug negative 3 in to solve for y. So negative 3 squared plus 6 times negative 3 plus 10. That's 9 plus negative 18 plus 10. That's going to give us 1. And then if you look at a table, if this is your vertex, a super easy number to plug in is 0. When you plug 0 in, you get 10. The same distance away from the line of symmetry as 0 is negative 6. So negative 6 is also going to give you 10. This data tells you that it'll never cross the axis. At negative 3, it's 1. At 0, it's up here at 10. This will have no x-intercepts ever. And the last problem to look at, to go ahead and write, is this. So if again we do our negative b over 2a, that'd be negative 6 over 2 times 1. So that's negative 3. If you plug negative 3 in, you get negative 3 squared plus 6 times negative 3 minus 3. 9 plus negative 18 minus 3 is negative 12. And then if you look at a table with this data, negative 3 gives you negative 12. Again, a super easy number to plug in is 0. 0 is going to give negative 3. That's going to match up with negative 6. We're still in the negatives. the spot where it goes into the positives is where the x-intercept's going to be. So if you plug 1 in, you get 1 plus 6 minus 3. So that would give you 4. Which means that negative 7 would also give you 4. This is telling us that our x-intercept is somewhere in between negative 6 and negative 7, and it's somewhere in between 0 and 1. We will learn the quadratic formula in a couple days to get those exact points, but right now, through graphing and estimating, that's all that you're expected to do. So, have a wonderful night. Thanks for tuning in.